Okay, so we're continuing with ratio questions part 2. There's going to be a mixture of different skills in this video, but we're going to start off with combining ratios. So it says here there are only blue, green and red pens in a box, and the number of blue pens to the number of green pens is 2 to 5. The number of green to red is 4 to 1, and there are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Well, I'm going to begin by writing down this ratio of the blue to green is 2 to 5. So blue to green is 2 to 5, and then they tell us that the green to red is 4 to 1. So green to red is 4 to 1. Now the problem here is the fact that the green ratio is 5 on this side and 4 on this side. So we need to get this ratio part that we've got here, we need them to be the same. In other words, we need them to match. So what I'm going to do is I'm going to multiply this whole ratio that I've got on this side, I'm going to times it by 4, and this ratio I'm going to times by 5 to get that central part to match. And then we've got them all compared with each other, which means we can then look at the next part of the question. So if I times this one by 4, I get that it becomes 8 to 20, not 8 to 5. And if I times this one by 5, I get 20 to 5, which now means I can combine these into one single ratio of blue to green to red, because there are 8 for the blue, 20 for the green, which is in both parts now, and 5 for the red. Now it says there are less than 100 pens in the box. At the moment, we've got 8 plus 20 plus 5, which is 28, 29, 30, 31, 32, 33. So there are 33 parts that we've got here. Now, because there's 33 parts, I could let each part be worth 1, 2, 3, 4, whatever I want it to, but I need to make sure that there are less than 100 pens in the box. So just taking this bit of working up here, I think because there's 33 parts, I think we can let each part be worth 1. Sorry, each part be worth 3. So if each part is worth 3, then we would have 99 pens in total, which is good because it says there's less than 100 pens. So we want to work out the number of red pens. Now the number of red pens is this section, and there are 5 parts, and we're saying that each part is worth 3 pens. So 5 times 3 is 15. So the greatest possible number of red pens is going to be 15. There are 15 red pens is the greatest possible number. So let's have a look. Yep, we have got that right for those 15 for that part. Okay, this one, there's loads of different ways of doing this one. I find this one a little bit tricky, so I'm going to try and show you in the way that for me makes the most sense. But of course, you could do this with an algebraic method, or you could do it in a different kind of way as well. So it says the points A, B, C and D lie in order on a straight line. Well, for me, it kind of is just going to be helpful to like have a line to help me visualize what's going on. And obviously they're in order, so A and D needs to be at the ends. The first part says that A to B and then B to D is 1 to 5, which must mean that B is much closer to A than it is to D. And then A to C and C to D is 7 to 11. So that must mean that the C value is closer to where D is. Now it doesn't have to be accurate like this, it's not accurate, but just needs to be like a visual tool to think of what's going on. So with the ratio, we've said that between A and B was 1, and then for the ratio that we have between B and D, it says 5. And then on the bottom, between A and C, I'm going to write that the ratio is 7 parts, and between C and D is 11 parts. So I've actually put C not in a very good place. In fact, I could quite easily change this. Let's put C so that it feels like it's in a more sensible location. Let's just erase this and put C in a slightly better place over this side, okay? So we're now going to say these are our ratios that we've got. Now you'll notice we can't really do this comparison because these are talking about different parts. So the bottom section has got 18 parts, which is the 7 plus 11. The top has only got 6 parts. So to be able to combine these and have them as sort of like the same comparison, I'm going to times this top part by 3 so that I also have 18 parts. When I times this by 3, I will get 15. And when I times this by 3, I get 3. So now that they're kind of talking in the same language, it should be a bit easier to spot what A to B to C and what C to D is. So because they're all in the same ratio, A to B is going to be the distance of 3 that we can see in the diagram. Now B to C is going to be the harder part that we've got here. We're trying to find out what is this gap that we've got. Well, I know that between A and C is 11, and between A and B is 3, which must mean between B and C should be 4, because 3 plus 4 is 7. So that means that B to C is 4. The last part we need to do is C to D, which thankfully is actually just already on the diagram, kind of like how the A to B section was. C to D that we've got here is just 11. So it's 3 to 4 to 11 for this part that we've got. Now there are other ways of doing this where you could call like the top part like X and 5X and the bottom part like different values and things with Y instead. But I just think this kind of intuitive method of comparing the parts and then combining the ratios does kind of work. So it's 3 to 4 to 11. Yep, we did get that one right. And you can see how this suggestion part they've got over here, that they've got X and Y as the idea of me saying you could call this 1X to 5X and 7Y, 11Y, that kind of stuff as well. It's just a little bit more complicated than this sort of intuitive method that we've got here. Okay, I'm just going to put this calculator to the other side. So this is a non-calculator question, and it's sort of combining ratios, but it's also got fractions in the question as well. So first of all, when they say that A to B is 2/5 and B to C is 3/4, we can change those from fractions to ratios, and then we're going to try and combine them as A to B to C. So if A over B is 2 over 5, that means that the ratio of A to B is simply 2 to 5. Because obviously the A part corresponds to the 2 and the B corresponds to the 5. Similarly, the ratio of B to C is going to be 3 to 4. Now the issue is that we've got the 5 and the 3 which don't match because our aim is to write them together. So what I'm going to do to this ratio is I'm going to triple it, and to this ratio I'm going to times it by 5. What that will do is mean that this B ratio will become 15 and this B ratio will become 15 as well, and it will all be comparable. So when I times this by 3, I get 6 to 15, and when I times this by 5, I get 15 to 20. Now that these match each other, I can combine this into one single ratio of A to B to C, which is 6 to 15 to 20, and obviously that can't be simplified because they don't share any times table at all. So let's check we got this one right. Yep, 6 to 15 to 20. Okay, so this is kind of like a sharing question. I've called it a changing ratio question, but I actually think you'll find this one pretty straightforward. So it says Tom and Adam have a total of 240 stamps, and the ratio of the number of Tom stamps to the number of Adam stamps is 3 to 7. Now, you'll see me doing this a lot in these questions. I kind of will like pause and just be like, okay, well, let's work something out. It's probably going to be helpful in the question. What you'll find is that's going to stop you being overwhelmed by the amount of information there is, and it means you're already going to get some of these 4 marks that we've got down here. So I'm actually going to pause, and I'm going to work something out. What I think I can work out here is how much they have. So we've got Tom to Adam, and the ratio is 3 to 7. Well, that means that there are 10 parts here because 3 plus 7 is 10. And they've got 240 stamps, so I'm going to share that by 10, which is 24. So that means each of those parts is 24. So Tom is going to have 3 lots of 24. This is a calculator paper, but 3 times 24 is 72 stamps. And then Adam is going to have 7 parts, which are 24. You can put that on your calculator. That is 168 stamps. Okay, so we've actually answered something. We've already got some marks before we've even finished reading the question. It then says Tom buys some stamps from Adam. The ratio of the number of Tom stamps to the number of Adam stamps is now 3 to 5. Okay, so something has happened. There has been some buying that has gone on. We're now going to look at the same question but with some changes. The ratio is now 3 to 5. Well, they've still got 240 stamps because they've just swapped them between them. We'll find out how many stamps they've got now, and then I'm going to read this last part that we've got. So there are 8 parts for this bit that we've got here for this ratio. 3 plus 5 is 8, not 3 plus 8 is 8. 3 plus 5 is 8. So I'm going to do 240. I'm going to share that between 8. So that's 30 stamps per part. So for Tom, he's going to have 3 lots of 30, which is 90 stamps. And for Adam, he's got 5 parts, and each part is worth 30, and 5 times 30 is 150 stamps. Now I'm going to actually read the question. It says, how many stamps does Tom buy from Adam? Well, he had 72 stamps before, and he's now got 90, so we can find out how many extra ones that he's got by doing 90 subtract 72, which is 18 stamps. You could also have had a look at what Adam had. Adam had 168 and now he's got 150, so clearly he has given 8 of them away. So the number which have been bought is 18 stamps. Yep, 18 is the correct answer for this question that we've got. Okay, let's have a look now at fractions of fractions. These are questions that are given to you in ratio, but you'll tend to find fractions become the best way of looking at these. If you can change them to fractions, you're going to find yourself answering this question way more easily, but they can be kind of confusing. It's a non-calculator one, so I'll make sure I don't use my calculator here. So it says white shapes and black shapes are used in a game. Some of the shapes are circles, all the other shapes are squares. So there's only black and white and circles and squares. We've got the ratio of white shapes to black shapes. We've got the ratio of white circles to white squares, and then black circles to black squares. And it wants us to know what fraction of all the shapes are circles. Okay, so what we're going to have here is we need to find out what fraction are white circles, and we also need to find out what fraction are black circles. And then what we're going to do is add them together to find out the fraction which are circles. So for the white circles, we know that out of all of the shapes that we've got using this ratio, because there are 10 parts in total, the white shapes are 3/10 of all of the shapes. And out of those white shapes, we're going to have a look at this section that we've got here. This section, out of these, that 3/10, we want to kind of split this 4/5 ratio for it. So the white circles for this ratio, there are 9 parts and 4 of them are white. So I've got out of those 9 parts, 4 of them are white. So we want to find out 4/9 of the white shapes that we've got here. So we're going to do 4/9 of 3/10, which is multiplication. I'm going to do the 4 times 3, which is 12, and the 10 times 9, which is 90. If I half the top and bottom, I will get 6 over 45, and I think I can divide this by 3, so I get 2 over 15. So now we're going to do the same thing, but for the black circles instead. So the proportion of the shapes which are black are 7 out of 10, and that's returning to this bit at the top. Now, these are the black shapes that we've got, and that is 7/10 of them. So the fraction which are going to be circles are the 2 out of 7 for that, because there are 7 parts in this ratio that we've got here, and 2 out of those are going to be circles. So we're going to multiply it by 2/7, because 2/7 of the black shapes are circles. So I actually could do a quick shortcut. You can see that these 7 are going to just divide, but if you didn't spot that, you're just going to get your 14 over 70. You can divide the top by 7 and the bottom by 7, and we can simplify that further, and we just get 1/5. So the circles in total are going to be the white circles added to the black circles, which is 2/15 plus 1/5. So that's 2/15 plus 3/15, which is 5/15, which is 1/3 that we've got here. So for this fractions of fractions, we should say that it is 1/3, which is the answer that we've got. Okay, we've got another of these kind of fractions of fractions, so I'm going to go a little bit faster for this. It feels quite similar to the previous question. A group of people went to a restaurant. Each person chose 1 starter and 1 main course. So we've got a starter and a main. The number of people who choose soup to the number of people who choose prawns is 2 to 3. So we've got our soup and prawns. Of those who choose soup, and of makes me think of multiply, which is just like the previous question. The number of people who chose lasagna to the number of people who chose curry is 5 to 3. Then we get told the same information, but for those people who chose prawns, and we want to find out what fraction of the people chose curry. This is like the circles in the previous question. So for the people who chose soup, if we go back to the original part that we've got here, using this, the people who chose soup are 2/5. There are 5 parts and 2 of them are soup. And of these people, of meaning multiply, we're going to try and find out how many chose curry. Now curry is the 3 section, so it's 3 out of the 8 parts that we've got there. So we're saying 3/8 of the 2/5 of people who chose soup chose curry, and we multiply those together because of usually means multiply. So 2 times 3 is 6, 5 times 8 is 40, so we have 6 out of 40. I'm going to simplify that and we get 3 out of 20. So that was for the people who had soup. For the people who decided to choose prawns as the starter, we're going to do the same process. So 3/5 of people chose prawns, and of those 3/5 of people, if we look down to this section that we've got here, 5 out of 6 people, 5/6, chose curry. Now we can do the cross these 5s out like this, but if you didn't spot that you could simplify that, we would get 15 over 30, and 15 over 30 immediately goes down to 1/2. So the fraction of people that chose curry, we've got the soup people who chose curry, which is this. The prawn people who chose curry is this. So the people who chose curry in total is going to be 3 out of 20 plus 1/2. That's the same as 3 out of 20 plus 10 out of 20, which is 13 out of 20. So we're looking for the fraction is 13 over 20. Yep, and that is the correct answer for this one. Okay, we've got one more of these questions. This one's slightly different because it doesn't have a fraction being multiplied together. This time it's like a fraction of another fraction written almost like as a fraction within two fractions. Sorry, two fractions written within one fraction. So it says there are 4 types of card in a game. Each card has a black circle or a white circle or a black triangle or a white triangle. And we've got the number of cards with a black shape to the number of cards with a white shape is 3 to 5. And the number of cards with a circle to triangle is 2 to 7. So I'm just going to highlight the key bits that we've got here. So we've got black to white is 3/5. Circle to triangle is 2/7. And it wants us to express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So because it wants it to be done as a fraction, we're going to be doing the black shapes as a fraction of those with a triangle. Now we can't write them as ratios, so we have to change these things that we've got here. We're going to want to convert both of these things to fractions. Basically, if you can make them fractions, you can do proper maths with them. So the fraction of them which are black, using this first part here, is going to be 3/8. And here's where I've got the fraction within another fraction. The fraction which are triangles are 7 out of the 9 parts. So we've got 7/9. Now, this isn't very nice to see a fraction written in this way. So I'm going to write this in a slightly different way. This is 3/8 divided by 7/9. And all we need to do now is keep this first fraction like this. You know how to divide fractions. We take that reciprocal of the last one and we change it from a divide to a multiply. So we just do the 3 times 9, which is 27, and the 8 times 7, which is 56, and we get the answer of 27 over 56. Now it's worth noting, I think this was the last question in the exam paper, because I think the wording is confusing. I think that the diagram doesn't actually help anything here. But look, the math is actually quite simple. So we asked for it as a fraction, so we looked at this, and we changed it all from ratios to fractions. Ratios are not nice for these kinds of questions. Let's double check we got it right. So 27 out of 56 is the correct answer for this one. I am going to stop though, because for the last video, I'm going to do ratio where it is combined with probability and when it is combined with algebra, which is one of the toughest parts of ratio.